Analyzing the Mercedes-Benz EQXX revolutionary concept, one of the main criticisms that electric cars face is the limited range and the far slower recharge speed in comparison with ICE vehicles. The main reason for this is the vastly lower energy content that their batteries carry compared to a fuel tank. There are generally two ways to increase the range of any car. The simpler way is to increase the capacity of the fuel tank. This is normally easy and cheap for a fuel-powered car, but quite the challenge and substantially more expensive when we are talking electric vehicles. The other way is to optimize all the aspects of the given car, from aerodynamics and rolling resistance to weight reduction. Mercedes-Benz EQXX went 1,008 kilometers on just one charge, with overall 8.7 kWh/100 km energy consumption and with an average speed of 87 km per hour. So Mercedes put in a big battery and made sure the entire vehicle is super efficient. Let's dive into how exactly it pulled it off. So EQ1010E, the Mercedes-Benz EQXX aerodynamics. The number one energy consumer in any car is the aerodynamic drag. While at speeds below 60 km per hour, this drag is not that high. At a typical highway speed, it is the most energy-intensive aspect of a car. The Mercedes-Benz EQXX has a CD value of 0.17 and frontal area of 2.12 square meters. That means that the total drag area is 0.36 square meters, which is extremely low. By comparison, Mercedes-Benz EQS, which is one of the most aerodynamically efficient cars currently on sale, has a total drag area of 0.5 square meters, minus 39% higher than that of the EQXX. Mercedes-Benz achieved it through targeted measures. The general water drop shape, 50 mm narrower rear part of the car, on-demand aero cooling, lengthening of the tail of the car in a combination of active and passive aerodynamics. The 20-inch wheels are totally covered to boost aerodynamic efficiency because they account up to a quarter of the total aerodynamic drag of a car. At 130 km per hour, which is a typical highway speed, the power requirements of the EQXX because of these measures are just 14 PS. Which is shockingly low. Powertrain: Mercedes-Benz claims 95% powertrain efficiency from battery to wheels, another highly impressive number. In the power flow between the battery and the wheels, we have three sources of energy loss: the power electronics, the motor, and the gearbox. To achieve this kind of efficiency, each of these three sources must have an efficiency of over 98%, something not currently possible in the mainstream automotive industry. We can make an educated guess regarding the motor though, which should be synchronous and more probably of permanent magnet type. The motor and power electronics, because of their very high efficiency, have very low cooling demands. The concept of on-demand, aero and liquid, cooling is used here to reduce aero drag and power requirements. The maximum power of the motor is 180 kilowatts, 245 PS. With the torque currently unknown, but it should be around 400 Nm. Bodywork: in the quest for efficiency, lightweight construction is mandatory. Even though electric cars have regenerative braking and the heavier they are, the more kinetic energy they harness, during a highway trip the regenerative braking is almost zero. The unladen weight of the EQXX is 1,755 kilograms, which is a technical highlight by itself considering that the high-voltage battery alone weighs almost half a ton. The EQXX is made of aluminum, martensitic steel, and carbon fiber reinforced plastic, while the wheels are made from forged magnesium. For the first time, aluminum brake discs have been used, which are lighter than traditional steel discs. The aluminum brake discs combined with magnesium wheels greatly reduce the unsprung mass of the car and improve the acceleration and ride comfort. All these materials are characterized by their lightness, while maintaining high stiffness and rigidity. In general, bionic principles have been adopted in the construction process and materials were used only where they were needed, thus avoiding excessive usage. This philosophy expands in the car interior with sustainable and light materials used all around. To further improve vehicle efficiency, solar cells are used on the roof. These only utilized for the low-voltage consumers such as the infotainment system, the air. Another first for Mercedes-Benz is the 900V architecture. This high-voltage value allows for super-fast charging of the battery with supported DC chargers, although in this case, this wouldn't be possible because of the passive air cooling that this battery uses. In general, it is possible to increase the electrical power through voltage or current. If we take the current approach, there will be a weight and space penalty because of the thicker cables. That's why it makes more sense to increase the voltage. Mercedes-Benz has also used a different anode material compared to the EQs, with the EQXX integrating high silicon anode. The usage of high silicon anode helped to increase substantially the energy density of the EQXX's battery to 200 Wh/kg, making it the most energy-dense high-voltage battery in the world. Using a carbon fiber lid and air cooling helped the battery to be fitted even in a compact car, according to Mercedes-Benz.